Okay, today we're going to deal with nonlinear systems of equations. Anyone want to make a guess what the heck I'm talking about?
Say that one more time.
It's up there.
Solving non-linear systems.
What, any idea what that means?
That means that things that aren't lines
Bingo, that's part of it.
are systems, so there's multiple of them.
That's correct. We've done systems of linear equations before. They can either cross, they can be parallel, or they can be the same line. Okay? Well, now we're dealing with nonlinear. Well, what is nonlinear? Anything that isn't straight. Circles, quadratics, radicals, yeah, cube roots, that sort of thing. Fifth roots, seventh roots for the final. For the final. Keep your eyes on Blackboard, emails, announcements. I may put a whole bunch of review stuff in the course materials that you can access. Nonlinear equations. Well, it helped if I put this in slide mode. If I want my clicker to work. There we go. Now it should work. Okay, this is just a definition. At least one of them has to be not a line. Now you can have a line with not lines mixed together. Absolutely, graphing helps to figure it out. Okay. Substitution method. Remember we had the addition method and the substitution method earlier. Generally speaking, with nonlinear, you almost have to use substitution because there's a characteristic of the addition elimination method is that you've got to have exactly the same powers in both equations. And for example, if we had a line and a parabola, a line just has x to the first power, and a parabola has x squared, or second power, second degree. So you can't use the addition method with those two, although you can use substitution. Okay. Okay, here are two equations. We just happen to have a line and we happen to have a circle. Okay. What am I missing? Minus 0, minus 0. So what's my center of my circle? 0, 0. Okay. So here's my circle. The center is at 0, 0. This, we change into y, I would change into y equal mx plus b format. Okay. I would do that, and I'll show you the steps on that if you wish. I'll show them whether you wish or not. Okay, I want to isolate that y. Okay, so first thing I'm going to do is take that over, minus x. So I've got negative 7y equals negative x minus 25. Divide by negative 7 everywhere. And I get y equals positive 1/7 x plus 25/7. That's kind of ugly. Okay. That's real ugly. But we can do it. I mean, we've got a slope of up 1/7. Up 1, 1, 2, 3, 4, 5, 6, 7. Okay. Well, let's deal with this. I mean, if you want to graph this line, you can do that. It's easier to do from this, even if you make an XY table, or you can do it from that up there. Basically, you're going to make an XY table and graph this line one way or the other. Okay. We see that this line and this circle intersect in two places. That's kind of to be expected. Okay. When we had quadratics and second degree equations, did we usually have two answers? When we had cubics, we usually had three, you know, and so on. You don't have to have that many, as some of them are a turning point. But I mean, that's just another clue for you. Anyway, you graph these two and you see they intersect right here. So the answer is simply this point, -4, 3, and that point 3, +4. That's not really all that difficult from a graphic point of view, is it? Assuming you can graph a line and assuming you can graph a circle. Okay. Well, here we go. Same problem. You see they put this in y equal mx, or actually I did. Put this in y equal mx plus b format. In here, h and k are both 0. We already discussed that. Okay, you can't use it in the addition method because the powers aren't the same. Okay, whoops, too far, too fast. Okay. Now, they chose to substitute for x, which actually was a better choice. Because if you substitute for y, look at this ugly stuff you got to deal with. So sometimes you may need to look at this and try it both ways and see which way it isolates nicer. You follow what I'm saying on that? Anyone not understand what I just said? Okay. So anyway, we decided to isolate this x. Well, good grief, it's already isolated. So just take this onto the other side. Okay. Well, anyway, here's my isolation value. Just like we had before with regular substitutions. So we're going to replace the x in this equation with 7y minus 25. Now, if you really want to think about it, we can consider that a substitution, or we can consider it a composition. Because all the composition is taking this and replacing that. Okay, well, anyway, let's do that. Okay, so we're replacing the x with this squared. So what do we got to do here? We got to take 7y minus 25 times 7y minus 25. 7 times 7 is 49. 25 times 25 is 625. They're on your multiplication, your exponents list, by the way. And then you got a middle term. It's 2 times 7 is 14 times 25. Well, it's easier to take 2 times 25 is 50, and 7 times 50 is 350 to do it that way, if you're doing mental math. Okay, everyone follow what I just said?
Yeah.
In this case, minus. Okay. And in this case, what I'm doing is I'm squaring this, right? 25 squared is 625. Okay. 7 squared is 49. Y squared is Y squared. Now for this is 7, that is 25, right? I can either take 2 times 7 is 14 and figure out what 14 times 25 is. Or I can take 2 times 25 is 50. And 50 times 7, because 5 times 7 is 35, with the extra 0 on the back end is 350. 350 Y. And that's a minus there. Okay? Well, because part of this is actually a Y. I just didn't show it because I was wanting to illustrate the numbers. Okay? So this part is all of that. 350, yes, thank you. That would really mess us up in this problem if that weren't there. It would. Okay, plus another Y squared equals 25. Okay? Well, this Y square added to those Y squares gives me 50 Y squared. Okay? I'm going to bring down this 350Y. And here, I'm going to take this over, so I'm going to subtract 25. And subtract 25 and get 600. Okay, so all of that equals 0. Okay. This is kind of an ugly sort of a thing. I can divide 5 out of everything. 10, 51, that, I keep dropping that, don't I? Okay, so let's take 50 out, giving me Y squared minus 7 Y plus, how many 50s in 600? 12 equals 0. Well, works. So I got 50 times Y minus 3, Y minus 4 equals 0. So my answers are Y equals positive 3 and positive 4. Now comes the unfun. We've got 2 separate Y values. So we got to substitute both of these into this to find out 2 separate X values. Does that make sense? Okay. You know what? I'm going to let them do it instead of me doing it. Okay, here's all the work that I just did. Okay, so that caught up to where I was here. I'm going to erase this now. But I wanted you to see how and why they actually did this. Now, if you didn't want to use that first square plus 2 times first times last plus last square trick, you actually could distribute it out and you get the same result. Okay. Now, so we're going to take the first equation, the line equation. And yeah, and we're going to substitute 3 into it. So we're going to replace that Y with the 3, and we end up with -4 for X. So that means we've got a value of y is 3 and x is -4. That's one of the solution points on this thing. Then we do the same thing with the 4 over here. And we're going to use the easy equation again. We could use the quadratic equation, we'd still get those two answers. It'd just be harder computation. Okay, so we get the 3 again. And in this case, we have the point 3, 4. Okay. If you remember from before, that matched what we had back here. There. Okay. See these 2 points? So I've shown you how to do it graphically, and I've shown you how to do it algebraic. Okay. And of course, there's your solution set. Now, what do we got here? We got a graph that's going to look like this. And we got a circle with center at 0. Basically, there's our graph. We're only going to have one point of intersection. Okay. Well, I just did that. I just did sketch them. Very crudely, I might add. Hopefully you won't do it quite that crudely. There's a little
We're
better.
talking about throwing some marks here. Did he show?
Yeah.
I'm not in.
Line, go, line. Guess where it is.
Actually, I used to do 3D graphic art on a computer, but for a couple of reasons, I decided to stop doing that. Okay. Well, now we're going to do algebraically what we did graphically. Oh, wait a minute. Let me back up. What was this point number? This point was 4, 2. Shouldn't be any ish to that one. Okay, so let's do it the substitution method. Okay, we're substituting this y with that substitution value of y. Well, square root of x squared is this. Take the 20 on the other side. You guys thought this might be a hard problem, but this one's easier than the last one. Okay, we got to factor that thing. What can give me a 1? Now remember, I've got a negative here, so I'm going to subtract them. 5 and 4 will give me 1 when I subtract. So my factors then are x plus 5 and x minus 4. Why did I choose this one to be the 5? Because that's a plus, and the biggest one gets whatever that sign is. See, that's the beauty of that factoring system I made up. Is you can just think through these without having to work them. Now, in this case, that -5, if this is positive here, that's -5. That -5 won't work. Okay? They checked it to see.
As long as you put it in y equals square root of x.
That's right, because on square root of x, you can't have that imaginary number in there. So that's why, and I'll write that down just in case anyone needs to be reminded of this. Y equals square root of x. Y is not that, or okay. Well, so 4 is our x value, which we had before. So what do we still got to do? We got to take that 4, or rather, we got to take this 4 and we got to put it into one of the equations and find the other y. Well, if y is 4, square root of 4 is 2. Done. What if we used, well, that's not the original equation. Yeah, it is. 4 squared is 16, plus 4 is 20, minus 20 is 0, 0 equals 0. Checks that way also. Okay, so it doesn't really matter which of the two original equations you used, except one of them may be harder than the other. So there's your solution set. Now we got a cubic. Everyone remember what a cubic looks like? In this case, through 0. Okay. Now, what does this one look like? Where's the only place they're actually going to meet? 0, 0. That's going to ultimately be our answer. Now, let's do the algebra. Okay, there are the two equations. We got an isolated y either place. So we can go either way. Well, in this case, they choose this one and did the replacement here. Okay. How do you get rid of that cubic or cube root? Cube both sides. You get rid of this cube root by cubing both sides. If that were a square root, you'd square both sides. Or we're a fifth root, you'd fifth both sides. That's not really proper language. Okay, so anyway, we do that. And we take this x over on that side and we got that. Out of this, we can factor out an x. That is a conjugate we can factor. So here are our 3 roots, or our 3 zeros, or solutions. We've got this one, which produces 0. We've got this one, which produces -1. And we've got this one, which produces +1. And x equals. You know what that means? We got 3 possibilities. We got to find the y values now. What?
The x on the y doesn't equal 1.
No, 0.
Oh, okay, I see it.
X equals 0.
Thank you.
Because you always individually take those equal to 0. Okay. So here are our 3 possibilities. Well, guess what? Probably those 2 are going to fall out. 10x, well, let's just go on. This is the same thing I wrote. Now, if x is 0, y is 0. Gives us the point 0, 0. If x is -1, then y equals -1. And if x is 1, then y is 1. Tell me when you're ready. It's nonlinear. So it actually does hit it in 3 places, not just the 1. Okay. So you can't just stop and say, I got the 1. If this was your answer, the point 0, 0, if you didn't do any of the rest of it, I'd still probably give you 2 points. Alex would probably only give you 1 point. Okay, there are a few equations that you can do by the addition method. You can still do all of these by the substitution method, but it's more difficult. In this case, the condition that allows you to do it is exactly the powers of the x's and y's must match on both. On both. Okay. What do we got here? Well, we got a circle here. Actually, we got an ellipse there. What do we got here? We got an ellipse there. We can use standard elimination. What do we try to do in elimination? We try to get an opposite pair. So what they're saying is they're going to take the top equation and multiply it by a -2, giving us that. Well, so far I don't have an opposite pair. Oh, yes, I do. Okay. So I do have an opposite pair here, which cancel each other out. Leaves me -3x squared equal -12. Divide both sides by -3. This was the last step on the previous. All I did was combine those and those, because these two cancel. Okay. Divide both sides by -3, and I get x squared equal 4. Take the square root of both sides, which this didn't show. Okay. And so that's how we got this. Square root of x squared is x. Square root of 4 is -2 in this case. Okay. Then I erase. Now, continuing. I've got these two x values, so I got to try that. Both, well, one's positive, one's negative. Well, here's the other side, and I still get a plus or -3. Either way. So what kind of answer do I get looking on this thing?
4 points.
Yeah. I have 4 possibilities. For +2, I have two possibilities, 3 and -3. For -2, I have two possibilities, 3 and -3. That's why there are 4 of them. Ta-da, ta-da. Ta-da. Anybody want to go home?